Hello. So this video is for P8 and probably we'll get to P9 too, hopefully. Good time. So P8 says what is the eccentricity of this ellipse. So I want to point you back to this sheet here that is available in your Google Classroom, and it's kind of got everything on it. It says, so we're going to look down here and we're going to find where it says that the eccentricity is a measure of how nearly circular the ellipse is. And the eccentricity is the ratio of C over A. And C is this distance right there, right? That's C, the distance from the center to the focus. And A is the semi-major axis. It's the distance from one of the vertices to the center. So, and you can see, if you put C over A, you can see that the smaller that C gets, the more circular this thing is going to get. The closer those two things get to the center, the more circular the ellipse is going to be. And if you take a look at the formula for the ellipse, you will see that if A and B are the same, then that becomes a common denominator, right? So you would have x minus h squared over, I'm just going to put a squared for the whole thing, minus y minus k, or plus, excuse me, y minus k squared equals 1. And now what can I do? I can multiply both sides by a squared. Those cancel out, and I get a squared over here. And what do I have? That's the equation of a circle right there. Because A is the radius, right? It's the distance from the center to a vertex. So A is the radius, and if the foci come together and are at the origin, you end up with the equation of a circle. Isn't that cool? I think it's cool. All right, back to this. So that's C over A. So keep this sheet on a tab or print one out or whatever, because it's going to come in super handy for solving all these problems. Now, erase that, go back here, and here we go. Okay, so we need to find the eccentricity of this ellipse, right? And what do we know? We know, what's this distance? What's that distance called? That distance is called A, right? And what's this distance called? B, right? So A equals what? 10. And B equals 6. And remember, A is always going to be the longer distance. A is the semi-major axis. The major axis is 2 times A. So if this thing was vertically oriented, A would be in the y direction. And yes, they can be tilted to the side too. I don't know if we get to tilted to the side ones or not. I can't remember. But anyway, so it turns out that the thing that we need to know for this A and B, because what we need to find is C, right? And C, if you remember, is the distance from the center to one of the focuses, foci. So the neat thing that happens here, though, is that this A distance also happens to be this distance right there. So that distance we already know. That equals 10. And B, what does B equal? B equals 6. We already know that. So the only thing you have to watch out for, is, this is obviously going to use a Pythagorean theorem, but your A, B, and C are different than the way we normally, than the variables that we use by convention. And of course, variables could be anything. We could use little pictures of bunnies and turtles and puppies if we wanted to, but that would take a long time. So in this form, when we're trying to find c, we are going to get what? We're going to get a squared, not a squared. Well, I could have done that. B squared plus c squared equals a squared, right? Because that a in this instance is the hypotenuse, and it's just the square of the two legs equal the square of the hypotenuse. So, but now we're trying to find c, so we're going to move b to the other side. So we got c squared equals a squared minus b squared, and then we can put the whole thing in, and we'll go c squared equals a squared is 10 squared, and b is 6, so that's 6 squared. So c squared is going to equal 100 minus 36. So c squared is going to equal 64, right? And that means square root of 64 is c equals 8. So so this distance there, c, that equals 8. And we'll put that up here, c equals 8. And now the eccentricity is just c over a, right? Let's double check it. We'll look at our sheet, and yes, it is c over a. So the eccentricity equals 8 over 10. So it's pretty eccentric, this ellipse. Sorry, I'm tired. All right, let's see if I got it right. 8 over 10. Oh, I got it. Oh, ha! Look at that. Because I forgot to simplify it. Well, there you go. The procedure was still right. I just did it wrong. We'll do another one. We'll do it a little quicker this time, of course. I forgot to simplify it. That was very silly of me, but it gives me a chance. Okay, so here we are. Here's our A. A equals, that's A. A equals what? A equals 7. And here's our B. B equals what? 6. So that's probably going to be a fairly non-eccentric one. Okay, so then we're going to have some sort of focus, and I'm just going to stick it in here. It doesn't really matter where I'm going to stick it. I'm just going to put it in there, right? Because that is, what's that distance? That's going to be our C distance, right? From the center to the focus. And we don't know what that is, but we do know that this distance is also A, right? So now we can say that B squared plus C squared equals A squared, right? And that means we can just isolate C, and we'll go C squared equals A squared minus B squared. And then we can just put all our numbers in. So we're going to have C squared equals, and then the A is 7 squared minus B is 6 squared. So C equals 40. Oops, I got my colors mixed up, moving too fast. Hey, come on. 49 minus 36 equals, what's 49 minus 36? Looks like 13, doesn't it? So C squared equals 13. So C equals the square root of 13. So C over A equals the square root of 13 over 7. And that's our eccentricity. And let's see if I got it right, shall we? Well, square root of 13. I got the last one wrong, so now I'm all nervous. Over 7. Ooh, I got the awesome. Excellent. All right. So we'll do another one. This one's a vertical one. So that means we just need to take care with our A's and B's, right? So let's just, and if you're just given numbers, the first thing you're going to want to do is sketch the ellipse. Okay, so there's our A, and there's our B, and B is going to be 5, and A is going to be 9, right? Yes. Okay, so now we're going to have our C, and I'm just going to make this up. I'll just stick it right there somewhere. That's our C. We still have to find. And the A is going to be the hypotenuse of the triangle. So let's put what we know up here. A equals 9, and B equals 5. So we want to know what C equals. And we know, looking at this triangle, that B squared plus C squared equals A squared. So C squared equals A squared minus B squared. Hey, it didn't register. I clicked it and it didn't register. B squared. So C squared equals, what's A squared? It's going to be 9 squared minus B squared, 5 squared. So C squared equals 9 times 9 is 81 minus 5 times 5 is 25. 81 minus 25 is 56. So C squared equals 56, which means that C equals the square root of 56. And now we gotta figure out if that can be reduced. So let's see, is 56 divisible by 4? 56 divided by 4. It is. So let's do this. That's going to equal the square root of 4 times 14. So that's going to equal the square root of 4 times the square root of 14. So that's going to equal 2 times the square root of 14. Can 14 be reduced any further? No. The first square is 4. You're looking for the perfect squares. If that's divisible by a perfect square, then you divide that out and then you square root the part that you can. So the first perfect square is 4. Nope. Second perfect square is 9. Nope. It's already too late. Okay. So then our answer is going to be C over A, right? So that's going to be 2 square root of 14 over A is 9. Well, that's a really ugly looking answer, isn't it? I hope it's right. Two square root of 14 over 9. I'm scared. All right, so I've done a couple of these. Now I'm going to just jump a level for the sake of time. Okay, so this graph shows what is its okay, so this is all about eccentricity still. Okay, so we're going to just do the same thing all over again, right? So we're going to have our A, that's our A distance, right? And what is the distance from here to here? It's 3. That's x equals 3, and that's x equals -1. So 3 minus -1 gives us a distance of 4. So A equals 4, and B is, oops, B is the shorter distance, whichever way it is, right? That's B. And what's B? B is going to be -6 minus -8, which is going to equal 2. And I know you can count it, but I just thought I would do the math because you might not always be able to count it, or you might be given points instead of a graph to interpret. Or it might have like 3 decimal places or something. So you just got to take one point minus the other point to find the distance. And it doesn't actually matter which way you go, because as long as you include all the signs, you're going to get it positive anyway. So, all right. So here we go. We're looking for C, right? And we're looking for C, something like that. That's going to be C, right? And so we remember that that's A right there, right? And then we're off to the races. I'm gonna go through it without changing pen colors now because that just takes a little more time. So we have B squared plus C squared equals A squared. So C squared equals A squared minus B squared, right? And so C squared equals 4 squared minus 2 squared. So C squared equals 16 minus 4 equals 12. So C equals the square root of 12. Is that reducible? Yes, it is, because 3 times 4 is 12. So you got the square root of 4 times 3, which equals the square root of 4 times the square root of 3, which equals 2 times the square root of 3. So that's C, and we're going to do C over A equals 2 times the square root of 3 over, what's our A? 4. All right, and we'll put it in. 2 times the square root of 3. Oops, I better back that whole thing out. 2 square root of 3 over 4. But, oh, what? Oh! I did it again. See, I'm trying to work too fast. Look, 2 square root of 3 over 4. What can I do there? Well, I can divide both. I can make this into 2, and I'll just do this long way. I'm sure you can see what I did already. 4 is 2 times 2, right? So now I've got a 2 times 2, and those 2's cancel out, and we're just left with square root of 3 over 2. So I had everything was right, except I forgot to simplify again. So there you go. But the procedure was right, and I got to model how I'm nowhere near perfect, which doesn't surprise anybody. So I'm not going to do another one of those. I'm going to bump it up a level. There's an ellipse. That's the same thing, right? You got your A. What's your A? It's going to be 10 minus 3. So A is 7. And B, so A is 7 and B is 6, right? And we're looking for C, and we know that if A is 7 there, this is also 7, and then you just got to go find it. And I'm going to jump a level again, see if there's anything harder. Oh, there we go. Look at that. Okay, good. Excellent. So now, what is the eccentricity of this ellipse? So we've got an A and a B in there already, right? A is the longer one. So A equals what? The square root of whatever's under the longer one. So square root of 25. So A equals 5. What does B equal? B equals, oops, I was going to use blue for B. B equals the square root of 21, which we're just going to leave all by itself because it is what it is. And now we have to find C. And you could sketch this out if you wanted to. You could, what's H and K? Let's just do this real quick. H equals 0 and K equals 0, right? Because the formula for an ellipse is x minus h squared over a squared, assuming that's the longer one, plus y minus k squared over b squared, assuming that's the shorter one, equals 1, right? So h and k equals 0. So a is 25 and b is the square root of 21. So it's going to be, so our center is going to be 0, 0. And then it's going to be our A, which is our semi-major axis, is going to be like there and there, assuming that's 5, right? And our B, whatever the square root of 21 is, square root of 21 is 4.5 of blah, blah, blah. So that would be like 4.5, somewhere there. And then it's going to go like that, right? So, but we don't actually have to do that because we already know, what do we know? We know, looking at this, that our C is going to be this distance right there. So we can use the exact same formula we have been using because A is the hypotenuse of this triangle. So A is 5 and B is the square root of 21. So remember the formula now, okay? So we're going to have, let me pause, get it right. So A is 5 and B is 4.5, and we're trying to find C, right? And our Pythagorean theorem formula with these letters is b squared plus c squared equals a squared, because a is the hypotenuse in our little triangle, right? So then we're going to have c squared equals, and of course, once you know how to do it, you don't have to sketch everything out if you kind of get what's going on now, right? I did that wrong because I'm trying to talk and do it at the same time. A squared minus b squared, and I hope somebody would have shouted out in class if they were listening. How are we doing? Oh, I got to get done. So then we're going to have c squared equals a squared 5 squared minus b is the square root of 21 squared. And we can do that, right? C squared equals 25 minus, what's the square root of 21 squared? Well, it's 21. So 25 minus 21 equals 4. So that means that C equals 2 and A equals 5. So it's C over A equals 2 over 5. And that is going to be the eccentricity of that. Two over 5. All right, and I am out of time, so hopefully that was enough. That got you to 72. Let's just, I'm going to hit jump. I'm going to clear this and then hit jump a level real quick to see if there's anything more that needs explanation. I don't think there probably is. No, it's basically the same thing. You got your A and your B there, and you got to find your C. A and B, find the C. It's all the same. Oh, challenge zone, what are they going to make us do there? Okay, so there, the only thing is, again, you got to complete the square, right? So you're going to have 4x squared minus 40x, and then you're going to complete the square on that, plus y squared equals negative 84. And you have to do the completing the square thing again to get an x in this kind of form, right? And then whatever this is. And that's that. All right, there you go. I'll try and get P9 done soon. Bye.